Okay, so welcome to part 3 of the video of 2.4. It is a big lesson and the math is not hard because really all you're doing is adding and subtracting exponents, but it just gets tricky, and this is where it gets tricky. So when do I use the laws and when do I use the order of operations? Because you're going to be getting questions that involve both. So now that we've learned some new laws, we can't forget that there is still an order of operations to follow. And again, when we have an expression does not have an equal sign. Notice that everything we've dealt with does not have an equal sign. We're going to be dealing with equations later, but expressions are evaluated or simplified. And that's why I have the word evaluating highlighted or capitalized, is because you evaluate expressions. That's the terminology you're going to see all the way up to grade 12. So let's do this example here. Let's simplify and then evaluate. Okay, so we have some power laws here. See how we're multiplying we're multiplying two powers with the same base. So really, we can use the product law to simplify first before we actually go on and evaluate. Okay, and evaluate means find me the answer. So in this case, since I have two powers and I'm multiplying them together, I can take this in the order of operations. You know how I put my little tray or my little highlighter? I'm going to simplify this to 10 to the power of 6. So that's how I get 10 to the power of 6. Now, I have not taught you a law that says when you subtract two powers, this is what you do. There's no law for that. So as soon as I see subtraction or addition, I know I have to go to the order of operations. So now I do order of operations. 10 to the power of 6 is 1 million. Remember that little trick. If I have 10 to the power of 6, there's 6 zeros. So 1, 2, 3, 4, 5, 6. Or else just do it on your calculator. So 1 million minus 10 to the power of 3, which is 1,000. And am I actually going to get the answer in here? Let's see. Am I going to? Oh, no. Sorry. Okay, so I'm just going to leave it like that because I can't move it. Okay, so you're going to get 999,000. Okay, so again, there's only laws for multiplying two powers with the same base and dividing two powers with the same base, not subtracting or adding. And that's when I know I have to go to the order of operations to evaluate. So let's do another example. Whoops. Oh, okay, so this is just a different way. Instead of using your power laws, you can just go right. You can use the order of operations right from the beginning. 10 to the power of 3, 10 to the power of 3, 10 to the power of 3, 1,000 times 1,000 minus 1,000. So I did all my powers first, and then I do my multiplication, which gives me 1,000,000, and then I do my subtraction. So you don't have to use the power laws. It just is a way to simplify it and make it a little bit easier. That's all. Plus, you're going to see that you're going to come across some pretty big numbers if you don't use the order of operations. And I bet you any money there's going to be questions on your exam that forces you to do the order of operations because maybe the numbers are, sorry, it's going to force you to use the laws of exponents because the numbers will be too big. So you're going to have to learn how to do it. But in this case, there's two different strategies. You choose which one you want in order to get the right answer. Okay, so it says simplify and then evaluate. So simplify using the power laws. So right off I can see that there's a power law here and there's a power law here, and I can't do anything in between because of that subtraction sign. Okay, so I'm going to use the product law to simplify. So here are my two trays because that is what I'm going to do first. So I'm multiplying two powers with the same base. I add the exponents. I'm multiplying two powers with the same base. Again, identity power. Let's put that 1 in there so we don't forget. I add the exponents. And now we can't do anything else because we have the subtraction sign. There is no power law or exponent law that deals with subtraction or addition between two powers. Okay, so please remember that. That's so important. So now that we have subtraction, you have to follow the order of operations. 2 to the power of 5 is 32. 2 to the power of 6 is 64. Oh, and I already see that there's an error here. It should be negative 32. Okay, so negative 32, not negative 64. Okay. Or you can just use the order of operations. 2 to the power of 3 is 8. 2 to the power of 2 is 4. Minus 2 to the power of 5 is 32. And then there's nothing there. Then we go and we do our multiplication. 8 to the power of 4 is 32. 32 times 2 is 64. And then we do our subtraction. And I did it again. Negative 32. Okay. So again, you can do it without doing the power laws, but just know that you have to know the power laws because there are questions designed around that. Okay, so what do I got next? Oh, a little bit tougher, a little bit tougher. So now let's write, we have negative 3 to the power of 4, but now the negative is not in a bracket. So let's rewrite it as negative 1 times 3 to the power of 4. We have a power law going on here because we're dividing powers with the same base. So we subtract the exponents. And then we have a subtraction there. We can't do anything with this power over here. Okay? So all we did was we used the quotient law just to simplify that division. This is the negative. We keep it out in front. It's like negative 1. Okay? Now what we're going to do is see how we're multiplying powers with the same base right here? Sorry, the way I get 3 to the power of 4 here is 6 minus 2. Okay, so that's that. Now I'm multiplying powers with the same base, so I add exponents. I get 3 to the power of 8 now. And now I can't do anything with these two powers because a subtraction sign separates them. Now I have to go to the order of operations. So 3 to the power of 8 times negative 1 is 6,561. And that minus 81 will give you negative 642. Okay? There's a lot going on. This is a pretty difficult question. If you follow the order of operations, you're going to get, we always do brackets first. So we're going to do, whoops, let me erase that. We're going to do our powers in our brackets first. So 3 to the power of 6 is 729. 3 to the power of 2 is 9. I'm going to do the brackets and this and my powers because you can do them all in the same step because they're not multiplied together or the operation's not together. So 729 divided by 9 is 81. 3 to the power of 4 is 81. And 3 to the power of 4 is 81. They're all kind of separate, so you can kind of do them at the same time. And then this whole thing is multiplication, so we have to do that next. Negative 6,561. And now I subtract. So same answer. Okay, so we want to write as a single power, which is not possible. So what I'm going to do is I'm going to reword this. I'm going to say simplify. I'm going to have to change this wording. And evaluate. Okay. So if you want to pause and try these on your own and then come back and check and see if you get the right answer, that would probably be good. Okay, so what I'm going to do in A is I'm just going to put that 1 in there so I don't forget. I have some powers going on there and I'm multiplying them together. I have some powers going on here and I'm multiplying them together. So this is 3 to the power of 2 plus 1. I can't do anything with this plus sign. And 2 to the power of 2 plus 4. Just using my product power law, or my product law, I get 3 to the power of 3. I get 2 to the power of 6. Now I have an addition, and it doesn't really even matter. Even if this was multiplication, the bases are not the same, so I can't touch them. So I go to the order of operations. 3 to the power of 3 is 27. 2 to the power of 6 is 64. And now I add them together. So I get 1, I get 91. Okay. And I fear I might need my calculator on the next one. We'll have to see. Okay, so we have powers here with the same base on the top, so we can use our product law. So I have negative 12, and I'm just going to add the exponents here instead of writing an extra step. I'm just going to add them. I'm multiplying powers with the same base. I add the exponents. Now on the bottom here, I have different bases plus a subtraction sign, so I can't really do anything. Let's put the 1 in already. 12 to the power of 0 is 1, so let's put that in. Okay, so now we're done as much as we can. And I have a feeling that I might need my calculator. So let me grab it. And for some odd reason, my calculator is not giving me, not going sideways. Oh, there we go. Okay, so 12, negative 12. Where's my, oh, to the power of 6 is, and it's going to be a positive, 2, 9, 8, 5, 9, 8, 4. Okay. And we have negative 2 to the power of 4. And I want to say it's 2 to the power of 4, 264. It should be 1 something. 2 to the power of 4. I went 2 times 4, believe it or not. Oh, geez Louise. I was thinking 4 to the power of 4 for some reason. This is equal to positive 16. Wow. It's too early in the morning. And it's going to be positive because we're multiplying an even number of negative 2's. And we have 1. So now we're going to go 2, 9, 8, 5, 9, 8, 4 over 15. Now, if this is reducible, which I don't think it's going to be, you would just leave it that as a fraction, or you might want to convert it to a decimal. Let's see how bad the decimal is. 8, 5, 9, 8, 4 divided by 15. Oh, okay. It's only 1 decimal place, so it's equal to 199,065 decimal 6. Okay, so it will tell you round to the nearest whatever. You know to switch it to a decimal. So if it doesn't say anything, you could give it either form. Your fraction must be in lowest terms, though. So that's pretty much the lesson. So we've really learned only 2 laws. We learned the product law, we learned the quotient law in this lesson. We've also learned that there's a 0 law. Anything raised to the power of 0 is equal to 1. And we learned the identity law, where anything raised, so 3 to the power of 1 is equal to 3, so it's just itself. So you have some assigned work, page 76 to 77, those questions. These are not hard questions. The math is not hard. These are very tricky questions, knowing when to use the power laws and when to use the order of operations. So it's a matter of seeing a whole bunch of different types of questions. The more questions you do, the better student, or the better your mark's going to be on your exam. If you want that 80% or higher, you better be doing number 20 on page 78. So if you have any questions or concerns, please see me in class.